simple. A sample of ideal gas contained over 240 cubic centimeter at 37 degrees Celsius and 100 Pascal. Okay, so we have uh, the ideal gas condition. Okay, how many moles of gas are present in a sample? Okay, let's use the formula of PV is equal to nRT. We know the value of R. PV is equal to nRT, the gas constant. Okay, P is 100 kilopascal, so it would be 100 into 10 raised to power 3, or 100 or 3 zeros more. Okay, then we have the volume, which is 240 uh, cubic centimeter. So if we want to convert it, it would be divided by this one. And if we want to calculate the lesser volume, we divide it with further like the different value. Okay. Okay, the next one is the temperature is not given. Okay, let's say nRT. The temperature is not given. Let's consider is it's 1. Okay, and then we have what temperature? Oh, we have 37 degrees Celsius. Okay, 37 degrees Celsius plus 273. So our answer would be 310. Okay, and the this constant is 8.31 into 10 raised to power something. So the value of R is 8.314. So okay, what we do now, N is equal to PV is divided by RT. So 100 into 10 raised to power 3 into 240 into 10 raised to power minus 6 divided by the temperature, which is 310, and the gas constant, which is 8.314. Okay, just divide it and your answer turns out to be 9.32 into 10 raised to power minus 3. Okay, the next question is, under certain conditions, the carbon tetrachloride and water react as shown. Okay, so the it's an exothermic reaction and an energy of minus 61.5 kilojoules is released. Okay, so the which enthalpy profile diagram is correct? First of all, we should know what is the like the profile. What is a profile diagram? So in the exothermic one, when we talk about the exothermic reaction, the energy of reactant is more as compared to the energy of the product, because the energy is released in the form of heat. So overall the energy decreases. So it can be like represented by A or D. So let's see which option is correct. So we have okay, what do we have? We have the reactant and we have the products. Okay, the reactant are written on in the correct place, and the products are also written on the like in the correct order. Okay, so which is the correct one? So I would choose D, because its shape matches the best with the graph as compared to the this A, because there must be some activation energy to start a reaction. So my answer would be A. Sorry, my answer would be D, not A. Okay, a helium ion contains two protons, two neutrons, and one electron. Okay, so the helium ion and a proton are passed separately through a uniform electrical field. Okay, so the particles are traveling at the same velocity. Which arrow describe the path of each particle? Okay, so when we talk about the helium ion, it is basically He, that is the noble gas. And when we talk about the proton, it would be hydrogen without any electrons. So because there are no electrons, no protons, so we call it proton. So it's basically hydrogen ion. Okay, so when we talk about which pathway is correct, so I would say that it would be um, helium ion would be okay. So they are deflected because they are positive ions, so they would be attracted to the other side, like here. So towards the negative side. So 1 and 2 cannot be there. Okay, 3 has no effect. Um, so they are positive ones, so they are needed to be deflected towards the negative part. So our answer would be 4 and 5. Okay, let's say what is it can be C or it can be D. So which option is correct? So okay, helium is heavier in weight than proton, so the proton would be 5 and helium would be 4, so my answer would be C. Okay, the skeletal formula of arginine and lysine are shown. Okay, so we know that these corner ones, these are the carbons. So okay, which row is correct? What is arginine and what is lysine? Okay, let's calculate the formula. It has how many carbons? One, two, three, four, five, six. Okay, it's C6. Okay, nitrogen, how many nitrogen? One, two, let's say, and two. Oxygen, one and two. We have two oxygen. Okay, and how many hydrogen we have? Two here, four, two here, six, two here, eight, two here, 10, two here, 11, one here, one here, 12, and 13. So it's not going to be simplified at all because 13 is there. Okay, so we are just cutting out the lysine. Okay, let's talk about the arginine. Arginine has one, two, three, four, five, six carbons. Let's say C6. I'm talking about the arginine protein. Okay, amino acid. Okay, then we have how many nitrogen? One, two, three, four. Four nitrogen. And then we have one, two oxygen. Let's talk about the hydrogen one. We have two and one. It will be three and one, four, four and two, eight, eight to 10, 10 and two, 12, 12 and two, 14, and one 13 over here, and 14. So age 14. Let's simplify it. It will be C3, H7, and 2, and 1. Okay, C3, H7, and 2, 1. So my answer would be A. The next one. The oxide and the chloride of an element are separately mixed with water. Okay, the two resulted in the solution that have the same effect on the litmus paper. Okay, so they both can be like the acidic one, or they both can be the alkaline one. What could be the element X? Okay, aluminum oxide and aluminum chloride, calcium oxide and calcium. Um, okay, then we have sodium oxide and sodium chloride, and then we have phosphorus oxide, and then we have what we have phosphorus chloride. Okay, so the only soluble one would be aluminum oxide and aluminum chloride, because the other oxide won't dissolve easily. So our answer would be A, and it would be like the amphoteric solution. When we talk about the aluminum oxide, these are like calcium oxide is basic, this one is basic, and this one is basic. So it's going to change the color of blue litmus paper only, not the red. When we talk about the aluminum one, it's an amphoteric one. It's going to change the color of both the red one and the uh, blue one, or because it acts as both acid and alkali when they went mixed in the like different solution. Okay, why do the halogens become less volatile as group 17 is descended? Okay. The first option is the halogen-halogen bond energy decreases. The halogen-halogen bond energy increases. The number of electron molecule increases. The van der Waals forces increases. So the halogen-halogen bond energy decreases. Bond energy. Okay. Basically it's converting from solid when we move down the group. So sorry, it is moving it's sorry it's it moved from like gas to solid. So the bond halogen halogen bond energy increases. Let's not talk about the bond energies, they become less volatile because okay, the number of electron in each molecule increase. Yes. Okay. So this can be the correct option. So this is all for this video. You can watch the other questions in the other videos.